We all know how function operations work. We obviously have done this in 1010, when we have f plus g of x, it just means take f of x, add it to g of x. We don't really have to be careful with the addition one. F minus g of x is f of x minus g of x. You do have to remember to distribute the negative to all of g of x. That's one of the things that gets messed up on. F times g of x times g of x, and then f divided by g of x. And we know that g of x cannot be 0 because you can't divide by 0. So if we need to put in a restriction, we can. We know all this, right? Already? Like, do you even need to write it down? Because it's really straightforward for us at this point. Okay, unfreeze. So it's just exactly what it says to do. We will do it. So let's see some examples here. Given f of x at the top and g of x at the top, it says find f plus g of x and then state the domain. So with addition, we don't really have to be careful. Our f of x is our x plus 2. So we have our x plus 2 and then added 2x squared plus x. So then our final answer we'll put in standard form. I'll put it down here. So it's x squared plus 2x plus 2. Now our domain, you'd look at it. Now you can look, what the domain is technically is both the domains combined. So do you see how it was a line and a quadratic? When we added them, it's just putting the domains together. Weren't they both all real numbers? And it's kind of easy, for the most part, you can just look at the new one. In the quadratics domain, left and right is negative infinity to infinity for a quadratic. So our domain for this would be all real numbers. Okay, let's do f minus g. So once again, f is x plus 2. We need to subtract all of g of x, so subtract x squared plus x. So then we know we'd combine like terms. I'm going to distribute my negative, so that'd be negative x squared. Then I'm going to have a minus x plus x. So my x's would go away, and then we have a plus 2. Now once again, isn't the domain all real numbers? Because it's a quadratic, so yes. Okay, f times g. So we do x plus 2 times x squared plus x, and then we just double distribute. X times x squared is x cubed. I'm going to write up here. X times positive x is plus x squared. Then we have a plus 2x, don't we? Wait. Yeah, plus 2x squared, and then plus 2x. So then my final answer is x cubed plus 3x squared plus 2x. And then once again, domain would be all real numbers because it's a cube, right? X cubed, there's no restrictions, so all real numbers. All right, g divided by f. Our g goes on top, it looks like, so that would be x squared plus x. And then our f is on bottom, x plus 2. And then that one has a restriction. And also we need to actually see if our answers simplify ever. So how do we simplify these divided ones? We factor the top, factor the bottom, restrict first, then divide. So on top I'll pull out an x, then left is x plus 1. On bottom an x plus 2, so nothing ends up dividing out. It's in our domain, x cannot be negative 2. So we can't divide by 0. So that'd be negative infinity up to negative 2. Then remember it jumps over it, union. Then goes from negative 2 to infinity, connecting us all the way through so that it's just not negative 2. So pretty straightforward stuff for the most part. So you probably can just watch this next one. It's up to you, but a little bit more advanced functions here. So given f of x is 1 over x minus 2, and then g of x is root x. So it says find f plus g. So 1 over x minus 2. And then add it to g, so plus root x. And we don't need to get a common denominator and do all that. We can just leave it. So from there, that's our answer. But then the domain is going to take some thinking, okay? Everybody, let's think about this. We did this the other day, though. Isn't it true that x cannot be 2 for this piece? But then for this piece, isn't it true that x needs to be greater than or equal to 0? So let's put the domains together. If it's greater than or equal to 0, it starts at 0, but then doesn't it get to 2 and have to jump over it? So then 2, parentheses, union, then 2 to infinity. Yeah, honestly, the hardest part is writing the domain. Good point. So now just subtraction. Instead of a plus sign, there's going to be a subtraction sign. So 1 over x minus 2 minus root x, and that would not change our domain. Our two true statements would be the same, wouldn't they? So I'm just going to point an arrow. That's our domain. Okay, let's do f times g, because this might change things a little bit, but it might not. Let's see. So f times g, so we would have 1 over x minus 2 times by root x. So technically, isn't that, we multiply straight across, recall. So we have root x over x minus 2. So then let's see our two restrictions. X cannot be 2, and then the same thing, right? X needs to be greater than or equal to 0. Okay. So then we already have done that once again in interval notation. Okay, f divided by g might come out a little bit different of domain. F, so we have this, 1 over x minus 2, and then divided by our function g, which is root x. Now that's really, guys, root x over 1. So technically, actually, when we simplify this, can't we flip and multiply? So we're going to times by 1 over root x. So our final answer would just be 1 over x minus 2 all times by root x. We don't need to distribute. But now our domain is going to be a little different, possibly. Let's take a look and set up some true statements. Okay. Okay, so the truth is, right, the true domain for this is the whole bottom cannot be 0, correct? So my true statement is this, x minus 2 times root x cannot be 0. Now this is factored, isn't it? When we have factors and we set them equal to 0, don't we solve by setting each of them equal to 0? So we're going to split it up. We can because it's factored. You guys see what I'm saying? So we have x minus 2 cannot equal 0, and also root x cannot equal 0. So then solve for x. X cannot be 2, and x cannot be 0, because we'd square both sides. Does everyone see? But now also, isn't it true, our second true statement, it comes from, isn't it true that what's under a square root, x needs to be greater than or equal to 0? Okay, now we just said it can't be 0. So we actually need to come and take off the equals to sign. So it says x only is greater than 0, we can plug in. We just have to skip over 0 and 2. So we're going to start at 0, aren't we? Not including 0. Up to 2, right? Because there's values between there, right? Decimals that we can plug in. 0 up to 2, close it. You can't be either of those. Union, then from 2 to infinity. So the hardest part is just setting up true statements for the domain. But we know the two restrictions, division, square roots, basically. Okay, you guys are doing good. Okay, so let's do the easiest ones here. Everyone, let's do this the easy way. It says take f plus g of 4. This is the same thing as this. F of 4 plus g of 4. It's going to be easiest just to calculate, add them together. Honestly, it's going to be quicker. So the function when I plug in 4, f, when I plug in 4, wouldn't that be 1 over 4 minus 2? So that'd be 1 over 2, right? Added to our function g when we plug in 4, so that'd be plus the square root of 4, so plus 2. So 2 plus a half, we would want not a 2 and a half. That's just not how we write math anymore. So we would get a common denominator, so we times by 2 times by 2. So wouldn't that be 1 half plus 4 halves, which is 5 halves, right? We add the numerator, we get a common denominator, so we can add the numerator. Good job. Okay, f times g of 4. So once again, okay, but look, we've already actually calculated. Okay, so look, that's f of 4 times 2g of 4. Haven't we already found f of 4? It was a half, wasn't it? So a half times the function g when I plugged in 4, wasn't it 2? So a half times 2 is 1, right? We multiply straight across. Wouldn't that be 2 over 2? So that'd be 1. Okay. F divided by g of 4. So f when you'd say that's f when I plug in 4 divided by g when I plug in 4. Let's carefully do this. F when I plug in 4 was a half, wasn't it? We have a half divided by the function when I plugged in 4, g of 4 was 2. Wasn't that 2 over 1? So dividing fractions is easiest by flip the second fraction and multiply. So what would be my answer? 1/4. We multiply straight across. Okay, very good. So honestly, it's not, the function operation is not the hard part. It's doing math right. You know what I mean? So just be careful. I have full confidence in your abilities. We have prepared for this. Hey, function composition. Just a reminder, FOG of x is not a times sign. It's an open circle. That literally reads F composed. of function g of x. Now, that is not times by x. It's always weird when I see people think that means times by x. No, that means rewrite this like this. Take x, squish it back in with g. That'd be g of x. Squish it back in one more time, so that's f of g of x. So we know that we would take g of x and plug it into function f wherever there's an x, correct? You just replace it. So let's rewrite this in the correct. Here's f of x, here's g of x. It says find f o g of x. Let's rewrite it. Squish it back, squish it back. So that would be f of g of x. We always plug in what's inside our parentheses. So you'd say, I'm going to find g of x. Isn't it x minus 1? We're going to plug it into function f wherever there's an x, replacing the x. So wouldn't that be the square root of, I don't know why I'm writing in the domain, but the square root of x minus 1? Isn't that g plugged into function f? And that's as simplified as it gets, correct? Now our domain would be what? Right? Underneath cannot be a negative, correct everybody? So how did we do it? What was our true statement? X minus 1 has to be greater than or equal to 0. What's underneath the square root has to be greater than or equal to 0, so we'd add 1. X needs to be greater than or equal to 1, so wouldn't that be 1 to infinity? Okay. Let's go the other way. It says take g o f of x, so I would just rewrite it, squish it back in, so that'd be g of f of x. So now instead we're taking f of x, which is this, and we're plugging it into function g. So that would replace it. So we have the square root of x minus 1. That's as simplified as it gets, but now what's our domain? X has to be greater than or equal to 0. Is everybody okay with this besides Axel? It's not confusing. Okay. X needs to be greater than or equal to 0. Because that's what was underneath the square root. And then there was no solving involved, so then 0 to infinity. Alright, awesome. Okay, so let's just make sure we're good with these. Do you want to try them by yourself, or do you want me to just keep plowing through? Just keep plowing? Okay, let's keep doing it. Okay, so which one? I could rewrite this. This is f of g of x, isn't it? So now I take g of x, plug it into this. Now watch, people have a hard time with this for some reason. This is getting plugged in right there, correct? Replacing it, so we have a square root. And then we have another square root of 2 minus x. It doesn't though, because one's not a square. Does that make sense? So this wouldn't cancel out. This is as far as it gets, technically, everyone. But we could, technically, guys, isn't this, this is probably how you'll see the answer written, but also, isn't this 2 minus x to the 1/2, do you agree? For this part, raised to the 1/2. Raise the power to a power and you multiply. So that would be 2 minus x raised to the 1/4 power. That might even be easier to look at for the domain, because now you might overthink it otherwise. Because isn't that just the 4th root of 2 minus x? And then isn't a 4th root domain is just like a square root domain. So our true statement would then just be 2 minus x needs to be greater than or equal to 0. So solving for x, we'd subtract 2. So negative x is greater than or equal to negative 2. Divide both sides by a negative. So that'd be x values less than or equal to 2. So think about what that would be. It's pointing this way. So it's coming in hot from negative infinity up to 2. So that's almost easier just to keep going with it and simplify it. Because I think we might have been like, well, what are we doing here? You know? I even had to pause for a minute and think. Okay, g back into g. Isn't that what this is saying? Take function g and plug it back into function g. So can anyone tell me what that would look like? The square root of 2 minus the square root of 2 minus x, like that. Does everybody see? Okay, now this one we actually can't simplify more. I'd be breaking the forbidden rule because of the subtraction sign here. So this is going to have to stay. So we could set up true statements. My first true statement would be for this piece. So wouldn't it be 2 minus x needs to be greater than or equal to 0? So then from there we would solve. We already know it's this. So x value is less than or equal to 2. But then my second true statement would be, isn't this whole thing also under a square root? So 2 minus the square root of 2 minus x needs to be greater than or equal to 0. And then we'll just solve for x here. Interestingly enough, I haven't ever seen one like this. I'm just going with what I know with math. So, I mean, I'm just setting up a new true statement. I haven't ever seen one of this caliber, but it's always, math doesn't change, so this is a true statement we need. So let's subtract 2. So we have negative the square root of 2 minus x is greater than or equal to negative 2. What's my next step? Divide both sides by a negative, then I got to change my inequality. So we have the square root of 2 minus x is less than or equal to 2. Then what? Square both sides. So we have 2 minus x needs to be less than or equal to 4. Subtract 2. Negative x is less than or equal to 2. And then divide both sides by a negative. What x values are greater than or equal to negative 2? What in the world? Let's think about this. Oh, okay. That makes sense, actually. So let's think about this. It says x values have to be greater than negative 2. True? We're putting the domains together. But doesn't it also have to be less than 2? Putting both together. Look. X values below 2, but greater than negative 2. So it's on an interval from negative 2 to 2. Does that make sense, everyone? Just putting them together. Ooh, that one was kind of tricky. I liked it. I like when we have to think a little bit. GOF of x. Okay, let's see what this... How about you guys try this one by yourself? Because this one has kind of an advanced domain like the one I just did. And me doing it for you, you might not actually be thinking quite enough. So try it, and then we can go over it if we need to. Okay, so when you plugged it in, you've got the square root of 2 minus the square root of x, and then your math came out to be that the domain was between 0 up to 4. Very good. All right, we're getting closer to the end here. Okay, what if I do 3? It's really pretty straightforward still. It's just now we have 3. So let's squish backwards. So x would be squished into h, so that'd be h of x. Squish it back into g. Then squish that back into f. Now don't we always work from the inside out? That's important. So you work from the inside out. You'd say, okay, the first thing I'm going to do is plug in h into g. So look, I'm going to plug h into g. And I'm going to write the answer, and that would take care of all of this. Does everyone see? So taking h and plugging it into g, wouldn't that be x squared plus 1 and then minus 3? So you say I'm doing the f of x squared minus 2, and now we have one last step. Take the function f and plug in x squared minus 2. Now, right, this is going to be plugged into function f, which is that, replacing the x. So we would have parentheses x squared minus 2 squared. We wouldn't break forbidden rules and then square that, right? So if that answer is appropriate, but also couldn't we rewrite it as x squared minus 2 times x squared minus 2 and double distribute and combine the terms if we really wanted, even though I'm not going to. I'm going to leave it in factored form. Okay, FOH of 1, we would take and we'd squish backwards, so that'd be h of 1. Squish it back again, f of h of 1. So now you calculate from the inside out. You say I take function h and plug in a 1. 1 squared plus 1 is 2. So then that says take the function f and plug in 2, which would be 4. You guys get the picture here? It's all familiar to you. Any questions? Yeah. Uh-huh. So I flipped it right there. Yep, if you divide both sides by a negative, you flip this side. Good question. Do I need to do GOH negative 2, or do you guys get how to do it? Okay. Cool. Okay. I feel like we probably get how to do these two. It's up to you guys. I just threw up a couple more examples to make sure. What do you guys think? Yeah, try either of these on your own. Go ahead. 50, once again, we have to be able to think advancedly. So there are multiple correct answers to this. Everybody watch. Create a function f as a composition of two functions. So it says, given function f, you create your own function composition that would create this. Don't overthink it. We just did 10 million function composition. What do we do? Take one function, plug it in the other. There's multiple correct answers. So it's just creating your own. Like, but it's got to recreate this. So, like, give an example. Try it out. It's okay to be wrong. So you said g of x could be? Okay, good. Yes. Do you guys see what she's saying? No, that's not. So you're saying, she's saying if, then you'd write, okay, so this is g of x, this is f of x, and then you know if you take g of x and plug it into f, it would recreate that function. There's many correct answers. We could have also said, do f of g of x, and then you could have done, let g of x be x minus 2 squared, and then f would be 1 over x. Do you guys see how that would work too? You take function g and plug it into function f, would it recreate this? Yes, so there's many correct answers. Okay, so like, try again. Everyone, create an f of g of x function or whatever you'd like. Just as long as it so produces, once you plug one into the other, the fourth root of x plus 9. Okay, what'd you do? F of x equal being the fourth root of x, and then really? Okay. F of x being the square root of x? Okay. But if you plug in a square root of a square root number, it doesn't produce a fourth. Oh, it does produce a fourth root. Wow, I wouldn't have ever thought of that. See, everyone thinks of different things. You said, then you plugged in the square root of x plus 9. That was very creative because I never would have thought of that. Very good. Yeah, that was awesome. So I would have gone the more easy option. Many correct answers. I like that you're thinking advancedly. So g of x I would have just called x plus 9. But I like yours just as much because it was extra creative. And so then you'd have to write out, and then I need to plug g of x in, so that's f of g of x. Just this, like that. This is plenty of information right now. Awesome. Okay. So if I think we get the picture, but it might ask you to do it of three functions, g of h of f. So that would be like this, g of h of f of x. So then what could be f of x? Square root of x. Well, you have to have an x, right? Otherwise you can't plug something in. So f of x could be root x. What would h of x then be? What is this plugged into? The cube root, right? Everybody? So then h must be the cube root of x, right? And then wouldn't that plug it in? And then after that, g must be what? X minus 1. Okay. You have to be able to think advancedly. It is kind of hard sometimes, but it's sometimes hard because you overthink it. So g of x would be x minus 1, h of x would be cube root of x, and then f of x would be square root of x. And then picture yourself plugging them in, and you would end up back here. Okay, this is the last example of the lesson. All right, last example of the lesson. Okay, it says a ship is traveling 20 miles an hour parallel. It's just going to be a function composition problem, but the hardest part is setting it up. So it says a ship is traveling 20 miles an hour parallel to a straight shoreline. So look right here. Here's the shoreline, right? This is a lighthouse, by the way. Here's the shoreline, and here's the boat's rate, travel pattern. Do you guys see how it's parallel with the shoreline? Now it's boat at noon, and then it's traveling boat after some more time. So it says right here, the ship, its rate, isn't it 20 miles an hour? Okay, then it says right here, the ship is 5 miles from the shore and passes the lighthouse at noon. So notice from here to here is 5 miles from shore because it's passing the lighthouse at noon, and there's a 5-mile distance between them. Now in part A it says, express the distance S between the lighthouse and the ship after time as a function of D, the distance the ship has traveled since noon. That is, find F so that S equals F of D. So basically let's just set up a true statement. So we have a right triangle here. So we know Pythagorean theorem would be setting up a S, D, and 5 problem, like setting up a distance problem. Because right here it says, express the distance S between the lighthouse and ship as a function of D. So isn't my true statement 5 squared plus D squared equals S squared? One side squared plus the other side squared equals the hypotenuse squared. It's a right triangle. The right triangle that literally looks like this. This was 5, this is D, this is S. So now it says it wants you to express the distance S between the lighthouse and the ship as a function of D. So it says right here, find F so that S equals the function with D. So it says it just wants it to be S equals. So how do we get S along now? Square root both sides, right? How do we get S? Just S. Square root. Now don't be mistaken, you can't just cancel out the squares because of the plus sign. So technically we have the square root of 25 plus D squared equals S. So now we have answered the function, we've written the function S as a function of D. That's it for A. And then it says express D as a function of time. So the time elapsed since noon, that is find G so that distance equals G of T. So our distance over time is going to depend on how many miles, right? There will be 20 miles per hour, so our D will be 20 miles an hour, so 20 times T. Because if they go 2 hours, won't it be 40 miles? You guys kind of see? It is kind of hard to think about. I think it's going to be a little bit more straightforward on the homework. Now it says, find FOG, because we found G. Why does it say? And what does it represent? So we're plugging function G into function F. Which one's function G? Oh, right here. Look, G. This is function F. So we're taking this one, and we're plugging it in right there, aren't we? So S is equal to, we have the square root of 25, and then plus our distance, which is 20t squared. So 20t squared. That's function composition. And then it just says, what does it represent? So let's think about this. Isn't this going to be, S was the distance, isn't it? So you'd say the distance the ship has traveled over time. Because now if you plug in time, you guys see that will tell you what distance you'll be at. So you'd say, distance from the lighthouse, or I think, yeah, distance over time would be good enough for me. All right, so the hardest part was it was kind of a confusing problem to set up, but I think though your homework will be more straightforward. I really do. Okay, ready? And homework is yours now.